guys, I welcome you to today's class. In our last video, we handled the introduction to electrolysis, and today we'll be treating the mechanism of electrolysis and the preferential discharge of ions at the cathode and at the anode. Now, let's now consider a situation where we have different types of ion inside a solution. Let's say in the same solution, we have sodium ions, we have hydrogen ions in the same solution. These are cations in the same solution. So what happens? Remember that in electrolysis, only one type of ion can be discharged at the anode or at the cathode and at the anode. We can liken this to a situation where you are traveling and then you have about 20 persons, imagine that, waiting for a bus, and then one comes by having only 3 chances, just 3. So that means you have to hustle, you have to struggle to enter inside this box. That's exactly what happens when we have different ions in a solution. So they will struggle and compete for the one that will be discharged at the anode or at the cathode. Now, we have three factors that will determine the ion that will be discharged. Now, the number one is the position of these ions in the electrochemical series. Number two is the concentration of the ions. Number three is the nature. So these are the three things that will determine the ions that will be what? That will be discharged. Now, let's consider the electrochemical series or the position of these ions in the electron. Listed here is the electrochemical series of the cations. So the position of these ions determines the ions that will be discharged at the cathode. Now, as we are going down the group, something happens. The electropositivity decreases as we are going down the group. Electropositivity decreases while the rate or the ease at which this ion should be discharged at the cathode increases. So as you are going down the group, the ease at which the ion should be discharged is as well increasing. For instance, in a solution where you have your hydrogen ion and your copper ion, the copper ion will be discharged because it is below hydrogen ion in the electrochemical series. The same is applicable to the electrochemical series of the anions. Considering the electrochemical series of the anions we have here. Now, as we are going down the group, electronegativity decreases. Why the rate or the ease at which these ions should be discharged increases. So, what am I trying to say? In a solution where you have your hydroxide ion and your chloride ion, the hydroxide ion will be discharged first or will be discharged at the anode because the hydroxide ion is below the chloride ion in the electrochemical series. So that's exactly what happens. The positions of these ions will determine the one that will be discharged either at the anode or at the cathode. So let's take an sulfate 4 solution. So that is what we have here as the electrolyte. But we have to observe something. When we're talking about dilute, that means that this solution is no longer concentrated. So that means there is an addition of water to it for us to dilute this very solution. So we have a solvent here. And take note, solvent brings about the reason why we have different types of ions in a solution. So whenever you have an electrolyte and then there is a solvent to dissolve this electrolyte, it will bring about different types of ions in the solution. And the solvent is usually what? Water. So the solvent will have water there to dilute this very compound. So the solvent here is what? H2O. So let's now look at the dissociation of what? The ions of this very compound. So dissociation. So the dissociation of the ions The copper tetraoxosulfate 6 solution will dissociate into copper ion and the sulfate what ion. So we're going to have this 2, so 4 minus 2. So that's what we're going to have there. And our solvent, which is water, will as well dissociate. So what do we have? We have H2O. It will as well dissociate into the hydrogen ion and the hydroxide ion. So this is what we have. So you can see that we have different type of what ions here. For the cations, we have two cations here, the copper ion and the hydrogen ion. Whilst we have two anions here, the hydroxide ion and the what? The sulfate what? Ion. So at this point in time, there will be competition among these ones for the one that will be discharged. So let's return to the anode should be the negatively charged ions, which is the hydroxide ion and the sulfate ion. These guys are migrating to the anode. Let's as well consider the ions migrating to the what? To the cathode. Migrating to the cathode, we will have our anions, cations, sorry, which is the copper ion and the hydrogen ion. So these are the things that will migrating to the cathode and the ones that will migrating to the what? Considering the ions that will be discharged either at the cathode and the one that will be discharged at the anode. Now, remember that we have the hydroxide ion and the sulfate ion migrating to the what? To the anode. So which one will be discharged? Which one will take much preference now? Considering the electrochemical series which we wrote down earlier, we're going to observe that the hydroxide ion is below the sulfate ion in the electrochemical series. Hence, the hydroxide ion will be what? Discharged at the anode. So here we have the hydroxide ion will be discharged. Also low hydrogen in the electrochemical series. Hence, copper will be discharged at the cathode, the copper ion. So copper will be discharged. The copper ion will be discharged. So the reason behind this is because that the positions of these ions are below others in the electrochemical series. Copper is below hydrogen, it was discharged. Hydroxide ion is below the sulfate ion, it was discharged. So this is just the principle.